Hello, welcome to Trigonometry Part 2, where in this second lesson, we're going to be taking a look at the other primary trig ratios, sine and cosine. So just to review, we are working with 90-degree triangles only. And with every 90-degree triangle, there's always going to be a side called the hypotenuse. And this is something that I made up, but we always need to have a focus angle when we're working with trigonometry problems. And so we usually label them as the Greek letter theta. Once we label our focus angle, we know that the side that's on the opposite side of that focus angle is coincidentally called the opposite. And the last side is called the adjacent. The last thing we learned was the first trig ratio that we learned was the tan ratio, which is tan of the focus angle is equal to opposite over adjacent. So remember, this is a relationship between the focus angle and how many times bigger the opposite is than the adjacent. And sometimes the opposite can be smaller than adjacent, so it could be a percentage or a decimal of the adjacent side. And we took a look at what angles, specifically angles greater than 45. Once it's greater than 45, then the ratio would be greater. And once it's less than 45, the opposite side becomes smaller than the adjacent, so it becomes a percentage. So in order to take a look at the sine ratio, I'm going to take a look at this situation here. So what we have is a person who's fishing, and there's a fishing rod here and a fishing line. And it's a really long fishing rod, and the line is being dropped down here, and there's a fish here. And so we can change the angle with which the fishing rod is making with the water here. And as you can see, there's question marks right here and here. This is my focus angle here, and this is considered my opposite side of my focus angle. Here, this question mark refers to the hypotenuse because it's across the 90-degree symbol here. So the ratio that we're working with today, or in this situation, is sine, because sine is defined. I'm going to define it for you right now. Sine relates this angle with the ratio of opposite over hypotenuse. Okay, so I want you to take a guess here as to what's happening here. I'm going to keep this angle 30 degrees, and I have, let's call this triangle A, triangle B, and triangle C. I'm going to have a very important question to ask you. Between triangle A, B, and C here, what's the relationship between the three of them? I hope you're going to say that they're all similar triangles, because they all have the same angles, 30, 90, and that last angle is forced to be 60 degrees because they have to add up to 180. So every single triangle here, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, okay, every single one of these are similar triangles. And as a result, there's going to be a relationship between this opposite and this hypotenuse. Actually, there's a relationship between all sides in terms of all ratios. But particularly in this case, we're looking at these two. What's the percentage of this opposite compared to the hypotenuse? And it's going to be the same every single time. What I want you to do is take a guess right now. How many of these will fit into there? 1, 2, 3. Is it the same for this angle? Is it the same for this angle? Okay. I'm going to give you a length here. So if that's 4, based on your guess, what is this going to be? If this is 3, what's my opposite going to be? If the hypotenuse is 1, what's my opposite going to be? Right, and let's take a look at what the answer is going to be. It's going to be 0.51. Okay, now that you know the similar triangles, if you know that this is 0.5 and this is 1, if I change my hypotenuse to 2, what's my opposite going to be? I'm going to repeat that question one more time because it's very important. If I change my hypotenuse, this fishing rod, to 2, a length of 2, what is my opposite side going to be? Hopefully you can make that prediction. It's 1. And if I change my hypotenuse to 3, what is my opposite going to be? Hopefully you said 1.5. And I think you get it. If I change to 4, that should be 2. By now, the bigger picture and the most important thing at this point is being able to make the relationship between the angle and the ratio now. A sentence, a concluding sentence. And the concluding sentence is, for every 30-degree triangle, the opposite is half the hypotenuse. That's what that means. And so I'm going to write out the ratio here. The ratio is what we're looking for. How many times bigger or smaller is the opposite than the hypotenuse? It's half all the time, no matter what happens. Right? It's always 0.5, 1.05, 1.1, 1.2, 1.3. Okay? So this is what this means. This is just a formula, but you have to be able to repeat that sentence one more time. I'm going to say it one more time because it's so important. Every 30-degree triangle, because this is sine, the opposite is half the hypotenuse. So when I see this, that's what that means to me. There's actually meaning behind this equation here. Okay, you should be picturing triangles, you should be picturing opposites, you should be picturing the hypotenuse every single time. Okay, and that's what sine means. Now, let's try to change another thing here. We're going to delete some of this stuff. What happens if I change the angle? So let's bring this down. Let's change it to an extreme, I don't know, 70 degrees here. Let's make it a little bit smaller. What percentage is the opposite compared to the hypotenuse? Right? And that's the same for every single situation here. Again, there's similar triangles here. And apparently we know, oh, sorry here, towards the end, I forgot to delete that. But you can see right here, for every 73-degree triangle, the opposite is 96% approximately. 96%. This is 96% of that length. Okay? And if I change it to like something even greater, for every what this means is that for every 81-degree triangle, the opposite is now 98%. Right? Do you see how the opposite side is now almost as long as the hypotenuse when the focus angle is really large? What happens if my focus angle is really, really small? What do you think the percentage that is of the opposite is of the hypotenuse? Well, let's make it really small. Let's bring down this thing. So let's go to like, I don't know, 10 degrees. And no matter what, we can change this length here. For every 10-degree triangle, the ratio stays the same, which is why it's really important to look at the ratio. The numbers may change because my fishing rod is getting longer and shorter. But the opposite, the ratio of the opposite to the hypotenuse is always going to be 17.4%. This opposite is 17.4% of the hypotenuse. Okay? So for small angles, it's going to be a small ratio. For big angles, it's a big ratio. All right, so let's summarize what we just learned a little bit. We know that if we have a very small angle, 13 degrees, we're going to get a small ratio. So take a look at this triangle. When we have a small focus angle, 13 degrees, the opposite is 22% of the hypotenuse, right? And you can see that for very small angles, the sine ratio is very small. The opposite is a very small percentage, 1%, 3%, 5%. The opposite is 7% of the hypotenuse. And as the angle gets bigger and bigger and bigger and bigger, we're going to get a bigger ratio. Like in this situation, we have an angle that's 67 degrees, right? And 67 degrees right here already states that the opposite is about 92% of the hypotenuse. So if I take a look at this is my focus angle, which is 67 degrees, and the opposite is going to be about 92% of the hypotenuse, pretty much the same length almost. Okay? Now, I made reference to this weird situation here. What is this? How can I have an angle that's 90 degrees? So here we go. We have an angle that's 90 degrees, and the ratio is 1. Right? So that you can see how the numbers get closer and closer to 1. We have 94%, 95%. The opposite is 96% of the hypotenuse. We're talking about the opposite being the same as the ratio as the hypotenuse. When you divide opposite and hypotenuse, it becomes 1. That means they're the same value. How is that even possible? How can you have a 90-degree focus angle? What I want you to take a look at is going back to the definition of a triangle here. It says in geometry, a triangle is a closed two-dimensional shape with 3 straight lines. It has to be closed. It's got to have 3 straight lines. This is a typical shape of a triangle. I'm going to have to kind of break your understanding of what a triangle really is. As long as it has 3 straight lines and it's closed, then it's still considered a triangle. So let's go back to the other go back to the other applet, and we can take a look at what happens there when we have a 90-degree focus angle. All right, so we're gonna try to make this get towards 90 degrees. So we have three sides, we still have a fishing rod, we still have the line, all right, and we still have the floor. We still have three sides. I'm getting closer and closer. You see how the opposite is getting closer and closer to the same value as the hypotenuse, so that's like 99%. This is 99.99%, this is 99.9999%, and then boom. At this point, the opposite and the hypotenuse is the same length. The length of the fishing rod is the same length of the rope here, right? In this case, it's 1.6, and this is also 1.6. So length of the fishing rod and the fishing line is 1.6. If I divide 1.6 divided by 1.6, it's still going to be 1. And this is the same for every 90-degree focus angle. If I have 1.1 as my fishing rod, see how the fishing line is getting longer and longer? It has to be longer and longer in order to reach the water there, right? And it's going to have to get closer and closer to it. And for it to reach the water, it's going to have to be the exact same length at 90 degrees, which is why it's 1. Okay? So, kind of broke your understanding of what a triangle really is. It's just as long as it has three sides and it's considered a triangle. And so we can actually write this for every 90-degree focus angle of a 90-degree triangle. So that's 180, 90, and 90 gives you 180. The opposite is the same length as the hypotenuse. Okay? So let's go back and summarize our learning here. So here, this is the same as the previous lesson where I was trying to explain that tangent is just another relation. You're relating the focus angle with the ratio of the opposite to the adjacent. Okay, and this is the same thing that we've been doing. We've been studying relations in grade 9 and grade 10 earlier this year. So here, this is the relationship now between all the other ones that I need to teach you. So this is trigonometry right here, sine, cosine, and tangent. Let me get my pointer here. So sine is defined as the opposite over hypotenuse. Cosine is defined as adjacent over hypotenuse. And tangent is opposite over adjacent like we learned last time. Okay, so these are just formulas and how they relate to each other. And some people love these triangles here to help you memorize, but the way I memorize it, personally myself, I just say so, ka, toa to myself. So, ka, toa. And I know that S represents the trig ratio, which is sine. C represents cosine, and T represents tangent. O represents opposite, and H represents hypotenuse. So this is going to be the numerator. Sine is equal to opposite over hypotenuse, which is what that is. Let's go to the other one we learned earlier. Tangent is opposite over adjacent. Toa, that's what toa means to me, opposite over adjacent. And the one that I haven't really talked about, I just have to define it for you, is just the last remaining ratio. You're just dividing the adjacent over hypotenuse. So it's the last ratio that kind of relates the other two together. Now there's something really wrong that triggers me with this graphic, and I was considering not using it, but it kind of shows how some people approach math. That's just a formula. Okay, remember in my previous slide I said it's a relationship. You can see how the ratios change according to how the angle changes. It's a relationship between angle and ratio, and that's what's missing very importantly right here in each of these three things. Sine is a relationship between the opposite and the hypotenuse and the given focus angle. Okay, all these three things are missing here, and so many resources online are missing that. Okay, they're missing the fact that it's a relationship. It's a relationship between the focus angle and the resulting ratio that's opposite and hypotenuse. Like if there's no focus angle, I can tell which one's opposite, sort of thing, right? And you're missing if they miss the theta here, they're missing the whole point between how it changes, right? How the angle is getting smaller and bigger, and as a result, the ratio gets smaller and bigger as a result. Okay, and it's really, really important for upper levels of trigonometry. Okay, so go on to the next video, and we can do a couple examples now on sine and cosine. That's what this lesson is going to be, sine and cosine, because we worked with tangent last time. All right, see you in the next video.